Good day everyone. My name is Eunice Fuichin with metric number 293900. In this video, me and my group mates will present about the integration of Internet of Things technologies in agriculture and smart home, a comparative perspective.
My name is Terki with matrix number 293926. I'll be discussing the 5 key clusters of Internet of Things. The Internet of Things cluster, which is green color, focuses on the importance of IoT in energy expansions and connectivity. It highlights the implementing IoT can enhance the energy efficiency, network connectivity, and the overall architecture. The network security cluster, which is red color, focus on the security of IoT. It highlights the protection of IoT device by using blockchain for distribution and secure data information. The deep learning cluster, which is yellow color, focus on IoT in the education field. It highlights the learning system based on AI in IoT can enhance features and services like identifying attacks, predictions, and autonomous decision. The human-centric IoT cluster, which is blue color, highlights the interaction between human and AI in IoT, including user-centered design, researcher distributions, and the use of AI in IoT systems. And the last one is the intelligent system cluster, which is purple color, focus on AI and automation process to enhance the IoT features and functionalities.
I will present about the network visualization of IoT in agriculture based on Scopus data. The farm automation cluster, which is green in color, showcases the integration of IoT in agricultural practices, such as adopting automation, real-time monitoring, and robotics in agriculture to enhance efficiency. The precision farming cluster, which is red in color, emphasizes on advanced farming techniques. It relates to data-driven decision-making to improve crops production and resource management. The irrigation management cluster, which is blue in color, revolves around soil and irrigation management, supporting precise water management and efficient resources use. The intelligent system clusters, which is yellow in color, represents the role of machine learning and artificial intelligence in cooperation with IoT in analyzing agricultural data to optimize productivity and decision making. Lastly, the Sustainable Innovation Cluster, which is purple in color, reflects the broader vision of a connected and sustainable agricultural system.
My name is Yap Tong with matrix number 293795. I'll be discussing the 4 main clusters in the Internet of Things in smart home. First, in red, we have the smart home and automation cluster. This focuses on how IoT is integrated into home to automate daily tasks, optimize energy usage, and make life more convenient for residents. Next, in yellow, we have the Smart Cities and Intelligence Environment cluster. This one looks at IoT role in shaping urban areas, aiming to create more sustainable and adaptive infrastructure, including intelligent building that can respond to environmental change. Third cluster, in blue, is the Intelligent System cluster. It focuses on the use of artificial intelligence within IoT. This enables devices to process data, make predictions, and even learn from user behavior, making the system smarter over time. Lastly, in green, we have the security and blockchain cluster. This addresses the crucial needs for protecting IoT networks from cyber threats, ensuring secure communication and data management, often with technology like the blockchain.
Next, I would like to introduce the propagation trend of IoT in smart home and agriculture. There are 7,459 documents of the agriculture sector with steady growth from 2020 to 2024 and a slight decline in 2025 due to the incomplete data. Smart Home has 6,680 documents and growth peak in 2023. This was a significant growth in 2024 with 1,207 documents. Overall, agriculture IoT show higher growth potential driven by innovation. Smart home IoT may be facing resource saturation or a need for AI integration.
Now we will proceed to technology overview. The Internet of Things, IoT, is a system or approach that enables real-world objects to connect, interact, and communicate through networking technologies. With the rapid advancement of technology, IoT is currently integrated into many devices and processes, enhance people's quality of life and providing easier access to specific information and services. IoT technology in agriculture describes a system where elements like crops and livestock, environmental factors, farming tools, and different virtual objects within the agricultural ecosystem are linked to the internet via information, sending devices that adhere to sharing and communicating information. IoT technology in smart homes facilitate the collection, exchange, and analysis of data from adaptability devices that monitor, allowing for remote assessment and rapid feedback.
The Internet of Things is revolutionizing both agriculture and smart home sector by enabling automation, real-time monitoring, and intelligent system control. In agriculture, IoT optimizes irrigation system, detect plant diseases, and monitor pest activity, improving the crop's growth and health. IoT integrates drone, sensors, and smart vehicles to collect crucial data for decision making, enhancing the productivity. IoT also ensures sustainability by supporting efficient water usage, monitoring soil nutrients, and managing livestock health. Advanced IoT applications enable traceability in food supply chain and use AI-powered robotics for automation tasks such as pest control and fertilizing. Additionally, IoT sensors are used to maintain the optimal storage condition for harvested crops, to reduce waste and preserving quality. In smart homes, IoT provide automation for home devices, enhancing convenience and energy efficiency. IoT sensors can measure lighting, temperature, humidity, and enables real-time control over mobile application. AI and fog computing supports personalized automation, such as optimizing energy consumption based on user preferences. IoT also improves home security with video surveillance, GPS tracking, fall detection, and emergency alert, particularly benefiting elderly or vulnerable individuals. Sustainable practices in IoT for smart home is supported by integrating renewable energy, such as energy efficient lighting systems.
Now we will proceed to the comparative advantages of IoT in agriculture and smart homes. The Internet of Things allows for real-time monitoring of crops and soil conditions and helps to manage water and nutrients efficiently. It supports timely decisions or irrigation, pest control, and fertilization. Real-time monitoring is not only monitoring agriculture, it also be utilized in fire detection. AI-based fire detection enhance the accuracy of monitoring, which helps in minimizing crop and infrastructure losses, reducing the environmental impacts of fires, and improving safety for workers and nearby communities. Besides that, IoT also supports better decision making through prediction analytics, improving crop quality and reducing losses, making it easier for farmers to plan ahead and increase productivity. IoT also facilitates early detection of issues like diseases, enabling quick interventions. It enhances operational efficiency and helps in precision farming by tailoring actions to the specific needs of groups. And lastly, IoT system enhance environmental protections. IoT promotes resources optimizing by reducing water and fertilizer wastage, increasing crop use, and minimizing environmental impact.
Let us start with the comparative disadvantage of IoT in agriculture and smart home. The first is the connectivity challenge. For agriculture, rural areas often lack stable internet access, and environmental factors such as terrain and weather further reduce network efficiency. Smart home rely heavily on a stable internet for device integration, and interruption can cause serious outage. The second challenge is cost barriers. High sensor hardware and maintenance costs make agriculture IoT systems unaffordable for many small-scale farmers. Smart home setup costs exceed $1,000 with ongoing expenses for update and maintenance. Next is usability issues. Limited technical knowledge among farmers lead to the underutilization of agriculture IoT systems. Unfriendly interface and the need for technical expertise in smart home discourage adoption. Last is data and privacy concerns. In agriculture, managing vast amounts of IoT data is challenging, and security risks can compromise sensitive farm information. Smart home IoT with re-encryption and open communication protocol increase vulnerability to hacking and unauthorized access.
Now I'll present on the comparative ethical considerations of IoT in agriculture and smart homes. The ethical considerations of IoT in agriculture and smart homes focus on four key areas: data privacy, accessibility, environmental impact, and security. In agriculture, IoT devices collect sensitive farm data, which, if not secure, can be misused, especially for smaller farmers who may lack control over their data. Similarly, in smart home, IoT devices track personal data, creating privacy risks through unauthorized access. Accessibility issues arise in agriculture where small-scale farmers may struggle to access IoT due to high costs, widening the digital divide. In smart home, varying level of digital literacy and incompatible devices can exclude certain users, such as older adults or those with disabilities. Environmental concerns include e-waste from IoT devices like sensor and smart meter in both sectors. It's crucial to design energy-efficient and recyclable technologies to reduce environmental impact. Security is a major concern in both fields. Breach in agriculture can compromise farm operations, while in smart homes, security flaws may expose users to risks like identity theft. Strong security measures such as encryption and access management are essential to protect user data.
The first future challenge is scalability and adaptability. IoT in agriculture needs to serve both smallholder and large farms while keeping costs low. For smart home, a lack of standardization among IoT devices causes integration issues, so expanding compatibility is crucial. Second is connectivity challenge. With wireless signal, unreliable power supplies, and limited internet access in remote areas significantly hinder stable data transmission and real-time performance for IoT applications in agriculture. For smart home, long-distance communication delay remain a challenge, affecting the seamless operation of IoT devices over extended range. Next is data management. Agriculture IoT devices generate massive volume of data, so it requires advanced analytics, efficient algorithms, and scalable storage systems to process and interpret this information effectively. In smart home, it is important to manage real-time data, demands the use of enhanced eco-computing technology to minimize latency and optimize bandwidth usage. For agriculture in remote areas, energy-efficient systems and sustainable energy sources are crucial to ensure the smooth operation of IoT devices. In smart home, high energy consumption and the growing issues of electronic waste, which is e-waste, emphasize the need for sustainable design practice. Last is device durability. In agriculture, IoT device must be durable to withstand harsh outdoor conditions, minimizing maintenance costs. For smart home, IoT devices require robust security features to prevent physical tampering and ensure safe, reliable operation.
In both agriculture and smart home, ease of use remains a challenge. For agriculture, simplified interface and localized training are crucial to bridging knowledge gap, while smart home needs improved user awareness and support to overcome technical barrier and resistance to adoptions. In terms of security and privacy, agriculture must focus on protecting sensitive data from cyber attack and ensuring trust in IoT systems. Smart home, on the other hand, face concern about unauthorized device access and data breach, requiring strong security frameworks and regular updates. For environmental impact, agriculture needs IoT systems to adapt to climate challenge, while smart home must address the environmental footprint and reduce e-waste. Cost and affordability are key in both sectors. Agriculture requires affordable IoT adoption, especially for smallholder farmers, with support from government policies. In smart home, financial barriers should be overcome to make technology more accessible. Finally, performance improvement are crucial. Agriculture needs IoT systems that adapt to environmental change and provide real-time insight for better decision-making. In smart home, enhancing real-time performance and CPU efficiency will improve user experience.
That's it for our group presentation. Thank you for watching.